Yes, good morning to everyone. Today we'll be talking about the Math Coprocessor, that is 8087. Okay, so that is coprocessor. Now, what do you mean by coprocessor? This is a processor which will work along with the main processor, that is 8086. So when you talk about 8086 and its coprocessor, then it is 8087. Now, in some of the ICs, 8086 will have on-chip coprocessor 8087. That means in the same chip, you will have this coprocessor also. 8087 is also 40-pin IC as we see with 8086, and most of the pins of 8086, okay, they are compatible. That means whatever the connections we are making between the 8086 and 8087, that is 8086 and 8087. So this thing we will study in the interfacing, because you have the interfacing of this also. So whatever the pins which are connected with 8087, the same name is also applicable for the pins of 8087. Okay. So when you understand the block diagram or the pin configuration, that then you will be able to understand maximum pins. जो pins के जो नाम हमने 8086 में पढ़े थे, the same names is also applicable here. Okay, there might be some very few pins which may have the name which is different from the pins name which we studied in 8086. Okay, so actually whatever the interconnection is made with 8086, the pin names are the same. Pin names are the same. That means their working and their significance remains the same. Okay, whatever the pins we have studied and that pins which are connected with 8086, their function remains the same. Their function remains the same. So what is this 8086 coprocessor? Now actually when you talk about this 8086 coprocessor, this is also called as Math Coprocessor. This is also called as Math Coprocessor. That means this processor along with 8086 can perform mathematical operations. Okay, mathematical operations. So that thing, when you understand the data types, that time you will be able to understand which are the numerical values it can handle. Okay, which numeric values it can handle. So if 8086 is can perform some other task, whatever the operations which are related with the numerical operations, that is your arithmetic operations, that can be taken care by the coprocessor. That can be taken care by the coprocessor. That means your mathematical, your arithmetic operations can be performed by 8087, and other than these mathematical operations, other operations can perform by 8086. So they are working in parallel. 8086 and 8087, they are working in parallel. Okay, when you talk about 8086 instructions and 8087 instructions, 8087 has its own instruction sets. Okay, so 8087 will write their own instruction sets, 8086 will write their own instruction sets to carry out some of the tasks. These instructions will be executed by both the processor and the coprocessor. Now which are the instructions which are associated with 8086? They will be performed by 8087, and whatever the instructions which are associated with 8086, they will be performed by 8086. Okay, and while executing, if some of the instructions which are suppose 8086 is performing some of the instructions, so 1 2 3 4, and in between if there is the instruction of 8087, okay, so you assume that red lines are the instructions of 8086 and the blue lines are the instructions of 8087. Okay, so in between, if there is an instruction of 8087, these instruction will be considered as NOP, no operation, by 8086, and same thing applies when 8087 is also doing the same thing. Okay, if 8087 is also performing its instructions, execution of the instructions, so blue color are the instructions of 8087, and while executing, if it founds the instruction of 8086, okay, then these three instructions will be treated as NOP, no operation. No operation will be performed. No operation will be performed. And one important thing, when we are executing the instructions of 8087, these instructions will start with the letter F. Will start with the letter F. So this is also important. Whatever the instructions are written for 8087 will start with the letter F, so that we'll be able to distinguish that 8086 की instructions कौन से और 8087 की instructions कौन से. Okay, and one important thing that instructions will be 11011, and this the most significant bits of all the 8087 instructions will be 11011. 11011. Okay, so that means most significant bits of all the 8087 instructions. I'm talking about the opcodes, okay, or the mnemonics, opcode or the mnemonics. So you know there are some mnemonics for every instructions. You have mnemonics. So every mnemonics, their MSB, most significant bits, will have this 1101. This is nothing but F. We are talking about the F. Every instruction will start with F, or else if you talk in terms of mnemonics or opcodes of 8087 instructions, they will be having the most significant bits will start with 11011. Okay. So what is the significance of 11011? These code is used to identify the 8087 instructions by the processor and the coprocessor. So this is your processor and this is your coprocessor. So they will be able to distinguish that these opcodes are related with 807, or the instructions which are started with F. Okay, so that is the meaning. Now we will move towards the understanding of the pin configuration of 8087. So you have understood that it is a Math Coprocessor and it is mostly used for carrying out the arithmetic and logical operations. Okay. Now we will be understanding the pin configuration. There is one important thing. This is also called as a Math Coprocessor, or it is also called as numeric data processor, NDP, numeric data processor. Numeric data processor. Numeric data processor, because it carries out the numerical operations. So that is why it is called as a numeric data processor. Now we'll understand the pin configuration. Before we start with the pin configuration, it is a 40-pin IC, DIP, dual inline package. Okay, and again I'm saying maximum pins are familiar to you. Maximum pins are familiar to you because they are associated with 8086. Okay, because it is working along with 8086. So maximum pins are familiar to you, and we will see the pin configuration now. So it won't take much of the time to explain you the pin configuration. So we will see. So I'll be sharing this PPTs with you. You can go through this. Okay. So multiprocessor, coprocessor, system comprising of two or more processors. Okay. Then advantages, why we have to go with the coprocessor when we have processor. Okay. So the advantages is mentioned here. Okay. Then the one I have explained to you that it is called as a Math Coprocessor or numeric data processor. It is working in parallel with 8086. And yes, one more important thing, when you are using this 8086 in maximum mode, that time only it will work along with 8087. In minimum mode, your 806 will not work. Okay, so that is the meaning that works in parallel with 8086 in maximum mode. So you have to bring your 806 in maximum mode first. Okay, yes, this is important. The features, please try to understand the features. Can operate on data of the integer. Okay, can operate on the data of integer. So which particular numerics we can cope up with, or we can use the data like integers, the decimals, and real types. Okay, and see the ranging, the length range from 2 to 10 bytes. The length ranges from 2 to 10 bytes. So these are the different data types: the integer, decimal, and real values. Okay. So what type of instructions we can do? It's like square root, exponential, tangent, etc. In addition to addition, obviously addition, subtraction, these are most commonly used. But other than this, multiplication, division, other than this, we can go with square root and exponential. Okay. The remaining features you can just see this, and if question asks, you can write down the features. Then we'll understand. We'll go with the yes pin configuration. Okay. Now actually the pin configuration here, they have made the groups. Okay, they have made the groups. If you want actually the pin configuration, that is from 1 to 40. Okay, that thing also you can refer. Let me show you that pin configuration. Okay, we will see the same thing. So I won't take much. I won't take much of the time for the explanation of this. Okay, because I already have told you most of the pins are familiar to you because they are associated with 8086. So for example, this is also 16 here. If you talk about the pins, I will go fast to make you understand. See, it is a 16-bit or multiplex address and data pins. So you can see here D0 and D15, they are multiplex with A0 to A15. Also 16 का तो हो गया multiplex. 4 multiplex pins are for address and status. For address and status. See here, address, the remaining address, that is A16 to A90 are multiplex with S3 to S6. Okay. So here also I can say it is having 20 bit of address and 16 bit of data bus. 20 bit of address bus and 16 bit of data bus. So similarly, जैसे 8086 का हमने feature देखा था, the same thing is applicable here. Okay. The only change is that 4 multiplex address and status bits. Okay, so that is the only difference we have. Otherwise, 20 address bus and 16 address bus. Then comes, so these pins are also are familiar to you. So we'll not go with the explanation of this. And you should know that these pins are input pins. These pins are multiplex and bidirectional. Multiplex and bidirectional. And why they have shown in this particular way, bidirectional one, why not in a single line? Because we have considered many addresses and many data, so they are bundled together. So ये तरीके से नहीं बताया है, because it becomes a single line, but it is multiplex and bundled. It is multiplex and bundled, so that is why it is shown in this manner. Okay. Even you are familiar with this RQ and GT, request and grant. So these pins already we have studied while explaining you the 8086. Okay. Then, so if you want the detailed understanding, you can go with this. The important thing which I need to explain here, that about BZ is that the BZ output is used as text bar input of the processor. So this is important. Okay. We are using the BZ output pin. This BZ output pin we haven't studied in 8086. This is a pin of 8087, but this is connected with test bar pin. And you know what is the function of test bar while explaining you the 8086. Okay, so you can just read this, and you can also understand the function of BZ output pin, which is connected with the test bar, Okay, so actually when we are using this particular test bar pin, this is usually it is written here, if the 8086 needs the result of some computation that is the 8087 is doing, before it can execute the next instruction in the program, a user can tell 8086 with a wait instruction to keep looking at its test bar pin until it finds the low pin. Okay, so while 8086 is performing some internal computation, that is operations, then before it executes the next instruction in the program, a user can tell 8086. Okay, so that means BZ जो pin है, that is actually telling to the microprocessor 8086 that I am busy with doing some computational work, and for that you have to wait for some time. So that is why it is providing some waiting instruction. So that is why this BZ is connected with test bar pin. This BZ is connected with the test bar pin of 8086. Okay. A low on the BZ output indicates that the 8087 has completed the computation task. जब तक ये BZ pin 0 है, जब तक ये BZ pin 0 है, that's why it is written here. The pin will be 0 till it completes the execution or computational process. And once it completes the computational process, then it will tell to the 8086 that now I am completed the computation, and now I am ready to for further processing. Okay, now I am ready for to carry out further tasks. That is the mean. Okay. So RQ bar and GT0, the same thing is applicable. What already we have studied. Okay. Yes, this is the one pin which is called as INT pin. Now regarding this INT pin, during an internal error condition, the coprocessor asserts the INT output as high, which can be used to interrupt the processor to take appropriate action. Okay. So if there is some internal error condition, then coprocessor asserts, then that case INT will be high. So when INT becomes high, this will interrupt the main processor 8086 to take appropriate action. So that is why this pin is important. Okay. Then we'll go to the next one. This is same thing. This is the जो हमने 8086 में पढ़ा था the status pin. The same thing is applicable here. यहाँ पे भी no operation. This is regarding the queue. When we are studying the instruction queue of 8086, तब मैंने पढ़ाया था QS0 and QS1. So please go through that. So here also it will give the status. Actually I am reading the status. ये जो सब input दिख रहा है ना आपको, these are actually to 8087 को समझना चाहिए कि what are the actual happening with 8086 में क्या क्या हो रहा है. So these are the input status पे. ये सब बताता है 8087 को कि क्या क्या status है वहाँ पे. Okay. So these are the bus status signals. These are the bus status signals which will indicate to 8087 कि what is actually happening in 8086. Okay. So that is the meaning. Yes, जो मैंने अभी बताया था NOP. So please go through this. This slide is also important. Okay. Actually ये बताता है कि हम जब 8086 और 8087 को properly हम जब both are working together, so what are the steps? पहले क्या क्या होता है? Okay, first what will happen, then second what will happen. So this slide will give you the working of 8087 with 8086 coprocessor. That is the main. So you can go through this. This is a flow chart to explain the previous slide. Now let me go to the different slide. Yes, this is important. This is a functional block diagram. This is a functional block diagram. This is a functional block diagram. This is also important, so you should know. So just I will brief you what is this functional diagram is telling about. Okay. Now this functional block diagram is divided into two parts. This is called as a control unit, and this part is called as a numeric execution unit. Your control unit, this control unit. So these are the two functional units, control unit and numeric execution unit. This control unit consists of what? Control word, status word, data buffer, then you have address and bus tracking. Okay, then you have exception pointers. Okay, so these are the different blocks, and one block which is shared amongst the control unit and numeric execution unit, that is operand queue. That is operand queue. This is called as operand queue. Okay, so mostly the numeric execution unit, it consists of 8 numbers of 80-bit register stack. Okay, now before I go with the understanding of numeric execution unit, try to understand the control unit. It consists of what? It consists of data buffer, shared operand queue, addressing and bus tracking, then exception pointers, okay, and control and status word. Now come to the numeric execution unit. This consists of 8 numbers of 80-bit register stack. This is more important. you can see a register stack is there. कितने है वो? 0 से लेके 7. That means total 8 register stacks are there. What is the size of each stack? 80 bits. What is the size of each stack? 80 bits. Okay. Then with this, the shareable operand queue, आधा यहाँ पे, आधा यहाँ पे. Then microcode control unit, exponent module, programmable shifter, arithmetic module, temporal register. Okay. So if question is asked, you can just briefly give what are the blocks are there. Okay. And the detailed explanation is not required, but you can just tell कि actually जब processing जब हम 8087 को working में लाते हैं तो पहले कहाँ से क्या होता है. Okay. So for that case, actually your NEU, that is numeric execution unit, is responsible for the execution of the coprocessor instructions. कोप्रोसेसर के जो भी इंस्ट्रक्शंस होते हैं वो यहाँ पे एग्जीक्यूट होते हैं, बट अंडर द कंट्रोल ऑफ कंट्रोल यूनिट, ओके. So your control unit transfers the numeric instructions to the microcode. ये दिख रहा है जो NEU instructions. So your instructions is getting transferred from here to the microcode control unit, of NEU. Okay. Now your the internally operates on all number of the 80-bit temporary real format. The 8086 has 8 numbers of 80-bit registers which are used as LIFO. Now, if you see this particular register stack, these are 8-bit and they are temporary real format. So whatever the opcodes instructions are there, जैसे हमने instruction queue देखा था 8086 में, वैसे ही इसका एक queue होता है, that is register stack, which is mostly is the form of LIFO. LIFO is what? Last in first out. हम पहले डाला second, third, fourth, fifth, sixth, seventh, eighth. जो लास्ट वाला डाला that will be first out. So it is last in first out. What was the condition in the 8086? That was first in first out. क्योंकि नीचे में हम output the नीचे में भी we were tracking that particular instruction opcode and that was given to the execution unit. I am talking about 8086 functional block diagram. Okay. यहाँ पे जो क्या है, यहाँ पे LIFO है, last in first out. Okay. So that is about this case. Then it has a 3-bit stack pointer to point to the current top of stack. अभी ये जो stack है इसका pointer कौन है? That is a stack pointer. और वो stack pointer हमें location कैसे बताता है? For that we are using 3 bits. The 3 bits will start from 000 to 111. 000, that is this location, to 111. 111 means 7. Okay. So you have the stack pointer which can hold binary values 000 से लेके 111 to represent the 8 registers of the stack. So that is a pointer. That is why it is called as a stack pointer. Stack pointer हमने 8086 में भी पढ़ा है. Okay. So the stack operates as a circular stack or fixed size 8 elements on the basis of LIFO. हम इसको rotate भी कर सकते हैं if required. Otherwise that is called as a circular stack or fixed. Fixed बोले तो 0, 1, 2, 3, 4. It can be any of the cases. Okay. Then upon the reset, the stack pointer is initialized to 00. तो हम जब reset करेंगे तो it will go to this particular bottom pointer, that is 000. Okay. So in register stack is more important. Now the comes, but this is more about the block diagram. Now we will talk about the data types. 8086 के data types कौन-कौन से? Okay. So it has the 7 data types. The data types are word integer, short integer, long integer, packed BCD, short real, long real, and temporal real. Okay. So if I want to give you the size would be the word integer, the size is 16 bits. Short integer, the size is of 32 bits. I mean to say that these are the different data types which 8087 can handle. And these data types, उनका size क्या है? So for word integer, it is 16 bit. Short integer, it is 32 bit. Long integer is of 64 bit. Packed BCD, this is of 18 digits. Okay. Packed BCD is of 18 digits. Now this 18 digits is nothing but 80 bits. This is nothing but 80 bits. 80. Remember 80 bits. bits. I'm talking about the packed BCD. I'm talking about the packed BCD. So this is 80 bits, or you can say 18 digits. Okay, 18 digits. जो हमने जो टेम्पोरली जो स्टैक देखा था, रजिस्टर स्टैक, उसकी साइज क्या थी? मैक्सिमम 80 बिट्स. So if I am handling packed BCD, maximum I can handle 80 bits. But other than packed BCD, the other data type, that is word integer, short integer, long integer, you have 16 bits, 32 bits, and 64 bits. Okay. Then there is the other one, that is short real, that is of 24 bits, long real, that is of uh, the 53 bits, and temporal real, that is of 64 bits. Okay, so these are the values. Now, even though they have given the precision, so you can, if I give you the actual range, for short real, I mean to say that the how many bits the short real can have maximum. So it can handle 32 bits. 32 bits. Long real will have 64 bits. Now actually here they have given the precision, लेकिन हम देखा जब देखते हैं कि साइज कितना शॉर्ट रियल में होल्ड कर सकता है, तो दैट इज 32 बिट्स. लॉन्ग रियल में 64 बिट्स, एंड टेम्पोरल रियल में है फिर से 80 बिट्स. इट इज 80 बिट्स. okay, that is 80 bits. So always remember, when you talk about the sizes, okay, it is word integer 16, short integer 32, long integer 64, packed BCD 80 bits, short real 32 bits, long real 64 bits, and temporal real 80 bits. Temporal real 80 bits. So this is about the, and see here most significant byte is mentioned here. So don't go with the understanding of this. You can just understand key what is the data format. And one more thing, integer, BCD, and real. So can I say your 8087 handles integers, BCDs, and real numbers? और उसके साइज के हिसाब से word, short, and long. Word, that is 16 bits, short, that is of 32 bits, long, that is of 64 bits, and temporal, that is of 80 bits. तो long यहाँ पे भी है, long यहाँ पे भी है, और दोनों का इफ 64 बिट्स. शॉर्ट यहाँ पे भी है, यहाँ पे भी है, दोनों का देखेंगे तो 32 बिट्स. ओके, पैक्ड BCD 80, temporal BCD 80, and if it comes to the word, then it is of 16 bits. So you can remember in this way. And this is just an interfacing block diagram. If it is asked to show you the interfacing block diagram, please show which are the important pins of 8086 and with 8087. Okay, so आपका जो main जो है ना, that is this one. This is your 8086 and this is your 8087. लेकिन दोनों के साथ बाकी क्या भी काम करता है. So it is 8259, 8284, and bus interface components if it is required. Okay, otherwise these two are important, and how these pins are associated with them you can just show. Okay, so this is all about your 8087. Please, the main important thing is the pin configuration, the functional block diagram, the data types, and if it is asked in short, you can just explain the functional block diagram. Okay, the most important thing is status, the register stack, that is more important. Okay, and what are the data types? So for data types I have explained in the previous slide, and if maximum time the interfacing questions are also asked, you can show the same diagram and you can elaborate on them. Okay, the pins कौन से connect होते हैं, and actually which are the pins which are connected with what pin. So the names are important. Okay, and their functions you can explain. So with this we will stop for today. Okay, thank you.